Now, in this class, we'll be studying the basic details or basic introduction to the Java programming language. That is introduction to Java. So the brief history, when you go back, actually before the existence of Java, the C++ was created, and before the C++, C was there, and before that there were many other languages like COBOL, BCPL, Fortran, and all. But the main the programming language which added more value to the programming world was C programming language, and that was the first accepted, that means first widely accepted programming language, because it was very easy and simple to write, and that was supporting more number of functionalities. So that was widely accepted programming language. C programming language was widely accepted, and that was invented by the team led by Dennis Ritchie in the year 1970. So it was the next step to the older languages that I told, BCPL and many other programming languages. So as the length of the earlier versions were having the difficulty that it was difficult to manage the programs as the length was increasing. To overcome that problem, what was required is object-oriented programming. That means we wanted to go for object-oriented programming. We have seen why the object-oriented programming was required on top of C. We have seen already. The C was structured programming, whereas C was procedure-oriented and C++ was object-oriented. That means in C, the most stress was given for the procedure or the code. That means what is happening. Whereas in C++, the most stress was given for the objects or the data. That means who is being affected. So that's why the C++ was required. And even though we were having C++, what was the need for going to Java programming language? The main reason for going to Java programming language is the C++ language was not portable, or there was a need for platform independent or architectural neutral programming language. What do you mean by platform independent or architecture neutral? Once you write a code on one particular architecture, that is, what do we mean by platform independent? Platform independent or architecture neutral. That means if you assume some architectures, architecture 1, architecture 2, and so on up to architecture N. That means hardware of the system along with the different system configuration. In case of C, and if you write C and C++ programs on one architecture, if you want to execute them on other architecture, then you have to go for major changes, because those programming languages, the code written with these programming languages is not portable. It is not portable. Portable in the sense you cannot directly take this and execute it on some other architecture. You may have to develop the code once again in some other architecture. That means reusability is not there. Reusability is not there when you go from one platform to another platform. That has to be noted when you go from one platform to another platform. Whereas if you write the code in Java, that is architecture neutral, or it is independent of the platform. If you develop the Java program in platform number A1, then it can be executed or it can be carried to any other platform with minor changes. That is, if you just develop the Java virtual machine for that architecture. If you just develop the Java virtual machine for that particular architecture. So this platform independent feature or architecture neutral feature was required for the programming language. That's why The Java is providing that particular feature. The programs written on one architecture by using Java can be carried to any other architecture. That's why the Java is called as portable programming language. Java is called as portable programming language. Right, as I said, the C and C++, they are designed to be compiled for specific target. As I said, specific target in the sense specific platform. They are not platform independent. They cannot be executed under different execution environment. But that was possible with the Java. That was possible with the Java because the Java programs are portable programs. Java programs are portable programs. And one thing you have to note here is Java is not an enhanced version of C++. It is not an enhanced version of C++. Java is not designed to replace the C++. Both are existing together. You should not consider that Java is next to C++. Both are existing together. C++ is also there and Java is also there. The only thing here is Java is having some extended functionalities on top of the C++. So it is not an extended version and it is not at all replacing the C++. C++ is still there, right? And what actually the different applications, what made the Java more strong compared to other programming languages? The very first entity what we can write in Java is applet. So what actually is an applet? It is a special program that is designed in such a way that you can automatically download it from the internet and execute it onto your browser. That's what is Java applet. So what actually the applet does here is applet will be using applet so many times in our day-to-day lives. So whenever you are sitting onto your computer and from the internet you are accessing some data. From the internet you are accessing some data. That means some online shopping you are doing. And whenever you visit one website, what happens? The corresponding small part of the code will be downloaded from the internet and it will be installed onto your browser. That is what is applet. So applets are the small program that will be downloaded from the server and they will be installed onto your browser. That will be installed onto the browser of clients. Browser of clients. And more about applets we'll be studying it later because they were reducing burden at the server side. Because like very similar to this user, many users will be accessing the same server. Many users will be accessing the same server. That means it is going to extend the functionality at the client side. Applets will be going to extend the functionality at the client side. That means whenever some information is getting transmitted from server to the client side, two types of information what we can transmit. What is that? First one is passive information, another one is active information. You can download two types of information from the internet. From the internet, you can download two types of information. One is passive, that means which is not an interactive. Another one is active, means it is going to take some input or dynamic information from the user. Say passive example is email. That means you will get when you open your Gmail account, some mail will be there in your folder that is on passive entity. You will simply read that mail. You will not do any interaction with that one. And another information could be you will install some applet onto the client browser onto your system. For example, when doing online shopping, there are some list of items. There are some list of items, and you will select at the right side. You want item number 1, item number 4, and item number 10. Like that, after selecting something, and you will click on submit at the end. You will click on submit at the end while performing online shopping. That means that is some interactive application that is called as active content within the applet or dynamic information present within the applet. Once you click on submit, and that will be taken and that will be sent to the server. So basically we can have two types of information processed in the applet, active information and the passive information. Details will be studied later. And the another property of the Java is security. When you download normal programs, what happens here is we may encounter many different difficulties by downloading viruses. So it usually happens that the viruses will be present in the programs, whatever we download from the internet, and they are going to obviously damage our hardware and software parts within the system. And whatever resources are there, we should protect them from the outside world. We should protect them from the outside world. So this protection is provided, or restriction is provided in such a way that the outside programs or Java applets are restricted only for the Java execution environment, and they are not allowed to access other parts of the computer. That is how we provide security, other parts of the computer. So I'll just extend this diagram only for understanding purpose. This internet, I am downloading some information onto the client. This monitor, I'll just simulate it for understanding purpose. Right? I am downloading applet from the internet, and assume this much space is reserved for Java execution environment. This is what? Java execution environment. This is what is Java execution environment, or the space reserved for execution of the applets whatever you download. The space reserved for execution of applets whatever you download. Right, when you download the applet, so the applets are restricted that they have to access only this part of the memory, or this part of the Java execution environment. At any given point of time, they are allowed to access only this part of the memory. They are not allowed to access this part, other part. They are not allowed to access other part. That means only some set of resources we are giving access for the applet. That is how we can provide security. In case of other programs, even if the virus is contained within this the program whatever we download, so they are restricted to access only this part of the execution environment. The other part will remain secure. This diagram I took just for explanation purpose, to make you understand the concept. Portability. So as I said, portability. The Java programs are portable. We can develop them in one architecture, take it and execute it onto the other architecture, and they are machine independent. You can write them on one machine and carry it to other machine. Similar to servlets, similar to applets, we have servlets. Servlets are also the programs. They are going to extend the functionality at the server side. They are going to extend the functionality at the server side, like how applets are for the client side or the browser, servers are for the server. They are going to extend the functionality at the server side. That means if this is client side and if this is server side, this is the server. For every client, what happens here is the server will create one servlet. The server will create one servlet. This servlet will serve this particular client. If one more client is there, then create one more servlet. If third client is there, create one more servlet. That means every servlet is serving one client. Every servlet is serving one client, and it's going to reduce the functionalities at the server side. That is one more strength of the Java programs. Right, and next coming to the Java development kit. Like how we need compilers for processing our C and C++ programs. For Java program, it was designed, the Java development kit was designed to compile and execute the Java programs. There were different versions of Java development kit, like starting from J2SE, and the functionalities are given, which supported some of the things called swings and virtual machines. These are different versions what we started. J2SE was implemented, and next to that J2SE 1.4, different versions of JDK. JDK is basically used for It is a platform for writing and executing Java programs. I will be demonstrating all the Java programs by using JDK only. In the further entire course, we will be using Java development kit for execution of the Java programs. Every version was containing some additions, and next we came with J2SE, that is Java 2 standard edition 5. That is Java development kit version number 5 was there, and the latest version number what we use in our entire course is Java standard edition 6. The edition number 6 we are using. That means whatever programs are there included in our syllabus, they are compiled on the Java development kit version number 6. Java development kit version number 6. So summary, you can understand what actually is a Java development kit. JDK is a platform. Earlier it was developed by Sun Microsystems. That was company which invented Java. That means which written JDK. But now the Sun Microsystem is acquired by Oracle company. It is not Sun now. It is Oracle company to create and execute the Java programs on various environments. JDK is required for compiling and execution or creation and execution of the Java programs. And we call something like Java is interpreted. The key feature of Java is Java programs output is not the executable code. It is a bytecode. That is what the bytecode will help us to carry the bytecode from one architecture to other architecture. See, you must know the difference between the interpretation and execution. Interpretation and execution. When you have the source file, and whenever you compile the program, what happens? In case of normal programming, C and C++, what happens? Executable file will get created. Executable file will get created, and then later we execute that file. Execution means all the instructions will be executed at a time. If this is a source file of C or C++, say for example, and if it is a source file of say Java, once you compile the Java program, what we get here is we get an intermediary form called bytecode. It is not an executable file. It is an intermediary form called bytecode. Then the purpose of this here is to support the functionality of support the portable nature of the Java programming language. That means this bytecode can be taken on any of the platforms. This is one platform, say platform 1, and this is platform 2, platform 3, and platform 4. There are different platforms or execution environments. Now, once we have this bytecode, the JVM can be developed for that platform. Every platform will be having the Java virtual machine, its own Java virtual machine. Then that bytecode can be taken and interpreted at the destination architecture. It can be interpreted at the destination architecture. So that's why it is going to support the portable nature of the Java programming language. It's going to support portable nature of the Java programming language. In case of normal, what happens? We'll compile the program and directly we'll get the executable file, and we'll be able to execute the file only at a time. Whereas in case of interpretation, what happens? Only part of the code can be executed. Interpretation, part of the code can be executed. And once we compile the Java program, we will not get the object code or executable code. What we get is, we will get an intermediary code called bytecode. and this bytecode can be carried onto other different platforms and it will be executed by using Java virtual machine. So that is the key difference between other programming language and Java programming language. So how it is portable? The purpose of bytecode itself is to be able to carry it to other platforms. That is platform 2, 3, 4. You can take it and execute it by using the JVM. And this is also going to support reusability. This is also going to support reusability of the code. Reusability of the code. Right? That's why the Java is called as interpreted programming language. It is not compiled. It is not compiled here. Once you compile, what happens here is you will get intermediary form called bytecode, and that will be interpreted at the destination. It is not compiled. What is interpretation? Only required part will be executed in the interpretation. So as I said, bytecode, that is also explained in this part itself. What is bytecode? After compilation, we will get intermediary form which can be carried to other platforms. That is what is bytecode. The next part is about bytecode. And Java virtual machine, it is used for executing the bytecode. JVM, it is used for executing the bytecode and it is designed as an interpreter for the bytecode. Right? JVM is implemented for each and every platform where you carry your Java program. That is, every platform, every destination platform has its own Java virtual machine, JVM, which can receive and interpret it. It can receive and interpret it. That's what the means of the use of Java virtual machine. All these are fundamental things. Just-in-time compiler. So what happens here is just-in-time compiler. Why do we need this just-in-time compiler? I'll take one help of diagram to explain the concept of just-in-time compiler. Right. So when we have the source code here, and we have the source code, that is Java. We're talking about Java now. When you compile this, what happens? We will get the bytecode. When we compile this, what happens? We will get the bytecode. Now, this bytecode can be carried to platform 1 and platform 2, so on. To any other number of platforms, it can be carried. And in these platforms, we have Java virtual machines for interpretation of that bytecode. And usual practice is interpretation will take more time. Interpretation will take more time. It is time consuming. Interpretation is time consuming, and compilation is execution is will take less time. Execution or compilation will take less time. Now, assume there are 100 lines of codes in this bytecode. Assume there are 100 lines of codes in this bytecode, which actually you are among these 100 lines, there are 10 lines which are important for you. There are 10 lines which are important for you, and those 10 lines you are executing repeatedly. You want to perform those 10 lines of operations repeatedly. Now, if you repeatedly go for interpretation, it will be time consuming. Instead of repeatedly interpreting, what you can do here is you can go for executing it. That means the bytecode are compiled for the benefit from the compilation. That means bytecode into executable code is converted by using the just-in-time compiler. That means it is going to convert into executable code. What happens? I want these only 10 lines to be executed repeatedly. Instead of going for interpreter, JVM has one part called just-in-time compiler, JIT. What it does here is it will convert the part of bytecode to executable code. It will convert the part of bytecode to executable code. So simple thing, what the just-in-time compiler does, just-in-time compiler converts the part of bytecode to executable code so that we can execute it at a faster rate, because that is the code which we want to execute repeatedly. To increase the performance of the system, we just convert that to executable code, and that conversion is done by the just-in-time compiler, which is part of the Java virtual machine, which is part of the Java virtual machine. And there are some of the features of Java programming language which we shall see it in the next class.